Hi students, I am Dr. Deepak Kumar, Associate Professor, Department of Computer Science and Engineering in St. Joseph Institute of Technology. So in today's class we will be discussing simple LR parser. Initially we will discuss, in this video we will discuss how to create LR 0 items. So we will have a problem discussing towards how to create LR 0 items. So this simple LR stands for, L stands for left to right derivation and R stands for rightmost derivation in reverse order. So we are going to solve this problem and we will do the LR 0 parsing and then we will proceed with the LR parsing table. Initially we will start with the first step. So step 1 will be creating an augmented grammar. So the augmented grammar is, if the start state is E, we will do it as E dash derives dot E. This is referred as a augmented grammar. Whatever be the start state, if the start state is S, then we will derive as S dash derives dot S. So this will be referred as an augmented grammar. So this will be the first step. And proceeding to it, we need to discuss on two operations, that is go to and closure properties. So the go to and closure properties are the two items that we are going to discuss over this problem that will help us to perform these iterations. So let's take first step, that is I will take E dash derives dot E. So after this dot symbol we have a non-terminal here. So whenever we have a non-terminal next to the dot symbol, that grammar has to be extended from the, so it will be E derives dot E plus T, and again if we see after dot we have E, but we have already in the form of performing the E closure operation. So E derives dot T. So after writing the productions of E, the next step we need to check whether again there is any closure is applicable or not. So after dot we have E here, that is already taken care. Next after dot we have a T, non-terminal T. So what we have to do is, here a closure is applicable. So the T productions has to be included. T derives dot T star F, then T derives dot F. After including this, again check for closure. As we discussed earlier, after dot we have a non-terminal T, that is already taken care, and here we have after dot we have a non-terminal F. So include those grammars here. Okay. F derives dot open braces E close braces, F derives dot ID. So again you check for closure operator. So after dot we have a open braces which is a terminal symbol, so closure is not applicable here. And whereas here after dot I have ID. Okay, so ID is also not a closure applicable because ID is a terminal symbol, so here also closure is not applicable. In such a way you can mark this as I naught, okay, because there is no more closure is applicable. Here comes the place of go to. Okay, so our aim is to move the dot symbol on the right hand side of each and every grammar. That is the role of this simple LR parser. So the first step we will write as go to I naught. So this is my initial state. Okay, so I am going to move the dot symbol from each and every grammar. I am going to move it one step to the right. So this will be one step to the right we are going to move. So go to of I naught comma E. So what happens, E dash derives I will get as E dot. So this dot symbol will be moving on to the right hand side. Next E derives, this dot symbol will move one step right. So it will be E dot plus T. So we have only the two grammars that has dot followed by E. remaining all grammars are of different forms. So only these two grammars are applicable for the go to of I naught comma E. So I will check whether any closure is applicable or not. So to check for the closure, after dot I should have a non-terminal. Here we have a terminal symbol called plus. So there is no closure is also applicable here. So that's all, this is over. Now you can name this as I1. The same way we are going to do it for remaining all. So next step, go to off. I am using the same state I naught. Since I have completed E, I am just for our understanding I am just giving a tick mark here. So next I need to do for T. So go to of I naught comma T. So these two rules have dot symbol followed by T. Yes. So what we have to do is E derives, we have to write as T dot. Then the next is T derives T dot star F. So check for the closure property. This is called that is the dot symbol has moved to the right hand side. Okay, this is called as a completed grammar. This T derives T dot star F. Okay, after dot I have a terminal symbol. So again closure is not applicable. Okay, so you can name this as I2. Next, I am going to be in the same state until I iterate all the dot symbol one step right. So now I completed E, T is also over, then I will go for F. So here go to of I naught comma F. So it will be T derives F dot. So no other production, no other grammar is of the form dot followed by non-terminal F. So you can conclude that. Okay, I am going to name it as I3 here. Next, go to of I naught comma, next is F derives dot E. Okay, I have completed this. The next is dot is followed by a terminal open braces. So what I will write is go to of I naught comma open braces. So what happens now, F derives, the dot is going to move one step right. So open braces dot E close braces. So after dot we have a non-terminal symbol. Whenever we have a non-terminal symbol followed by a dot, then there is a closure property applicable. So closure is applicable here. So what is the rule of closure? Whatever the non-terminal, that non-terminal has to be included in the iteration. So E derives, I will take it from here, E derives, I will write as E derives dot T. Then again I will, sorry, E derives E plus T, then E derives dot T. Now for this closure, I have included two rules, that is E derives dot E plus T and E derives dot T. Now you check for the newly introduced rules, that is after dot I have a non-terminal E. Since I have already taken care, I am just ignoring it. Then E derives dot T. So a closure is applicable here. So what I have to do is T derives, I have to extend from here, T derives dot T star F, T derives dot F. Again check for closure. As we discussed, after dot non-terminal T is there, but already we have taken care of that, so I am just ignoring it. Again we have dot followed by a non-terminal F. Yes, closure is applicable here. So what I will do is F derives, I will write as dot open braces E close braces, then F derives dot ID. I am going to name this as I4. Next, go to off. Now we have done with F, that is open braces. Next is F derives ID. So what I will do is go to off I naught comma, we have a term, that is after dot we have a symbol referred as ID. Okay, that is a terminal symbol. I will write as ID. So now what happens? This F derives ID dot. As we discussed, now this is this can be said as a completed grammar because the dot has moved to the right hand side of the grammar. Okay, so no more operations are possible further here. Let me name this as I5. Now we have done, that is, we have moved one step right of all the grammars that is available in the I0. So now we have done with I0. Now we will move on to I1. So we will write as go to of I1 because I am moving to the next state called as I1 state because I have done all with all the grammars. It is done in I0. Next in I1 we have two productions, that is E dash derives E dot. As I told you, that is a completed grammar, no other operations are possible in that. Okay, we will discuss further regarding using this in the parsing table. E derives E dot plus T. Okay, so this is a place where we are going to use the go to operation. So we are in state I1. Okay, so in I1 state, the dot has to move one step right of the plus symbol. So I will write go to of I1 comma plus. Now the rule, now the production will be E derives E plus dot T. So after dot, this dot has moved one step right now. Okay, from here it has moved one step right. Now this dot is followed by a non-terminal T. As discussed, closure is applicable here. So now we have to extend the rule of T derives dot T star F, then T derives dot F. After dot we have a non-terminal T that is already taken care, so I am ignoring this closure property here. After dot I have a non-terminal F, so this non-terminal F again we have a closure here, this has to be taken care. So I will include the rule F derives dot open braces E close braces, then F derives dot ID. So I have just extracted from here. I need to check, okay, since we are previously I1, I2, I3, I4, these states we are extracting from I0, we have not checked for the same iterations, whether there is any occurrences of the same iterations. In further, before you naming this status I4, I5, I6 like this, before you naming it, you need to cross check whether you have the same set of iterations. Okay, so this type of iterations we call this as LR of 0 items. Okay, so we need to check whether we have the same kind of LR of 0 items before we are proceeding to name this as a new state. So let's check whether we have in that form or not. So we have the rule starts with F. Okay, so as of now we don't have. So let me name this as my I6. I will close this, then go to. So in I1 I had completed. Okay, so I am moving on to the next state called as I2. So I will write as go to of I2 comma, as we discussed E derives T dot, we will not be able to do any operations there. So what is the next step is T derives T dot star F. Okay, so we have a dot symbol that needs to be moved one step right here. So what we are going to use is go to of I2 comma, it's a star symbol, it's a terminal symbol. So my production will be T derives T star dot F. After dot we have a non-terminal F, so closure property is applicable here. So we will extend F derives dot open braces E close braces F derives dot ID. So after dot I have only a terminal symbol, and here also after dot I have a ID as my terminal symbol, so no other operations are possible. So I will name this as I7. Next, we are done with I2. Then we are supposed to go for I3. So please check the state I3. It has a production T derives F dot. That means no other operations are possible, because in the beginning itself we told our motto is to bring the dot symbol on the right hand side of the grammar. So it is already done now. So you can skip that state I3. Then directly go for the next state called as I4. So go to of I4. Now as we did in I0, we have to do for the same for in I4 also. You need to do you need to shift this dot symbol one step right for all these grammars here. So first we will start with E. So go to of I4 comma E. So we have two productions that follows this closure property. After dot I have a E here, then E derives dot E. So these two rules will be applicable for this go to operations. Okay, so F derives open braces E dot close braces, then E derives E dot plus T. So this is the, okay, now we need to check whether we have the same names or not. So there are no names, then we can name it as a new state. Let me name this as new state. I will name this as I8. Next, go to of I4 comma, next is T. So go to of I4 comma T. Now E derives T dot. So E derives T dot is the production, that is go to of I4 comma T. So I4 next is T derives T dot star F. Since first production it is E derives T dot, no operation can be performed. Then T derives T dot star F, dot is followed by a star symbol, closure is not applicable, that's all. We will close this with a, before naming it we need to check whether we have the same rule. Okay, so check here, E derives T dot. Okay, please see this I2, E derives T dot, here we have T derives T dot star F, both has the same. Okay, so then you are not supposed to give a new name, you are asked to reuse it. So go to of I4 comma T, we will name it as I2. Next, go to of, still we are in I4, we have F here. Okay, so go to of I4 comma F. So we will get T derives F dot. So already it is in I3. Okay, we will name the same here. Next, go to of I4 comma, it is open braces. So go to of I4 comma open braces. So now I will get F derives open braces dot E close braces. As we are discussing, after dot I have a non-terminal, so closure is applicable. E derives, I will take it from here, E derives dot E plus T, then E derives dot T. Next we have to check for closure. Dot, after dot I have a non-terminal E, that is already taken care, so I am just ignoring it. After dot I have non-terminal T, I will include because closure is applicable here. So T derives, I will take it from here, T derives dot T star F and T derives dot F. Again we have a closure. As discussed, I am ignoring this dot after dot I have non-terminal t because already we have taken care of this. So t derives dot f, here closure is applicable. So I will write f derives dot open braces e close braces, then f derives dot id. So after dot I have terminal symbol here, and after dot I have a terminal symbol id, that's all. Okay, so we can close this, and before naming this we need to check whether we have the same pattern. So please check for this I4, both seems to be same. So in that situation you are not supposed to have the new name for new state name, instead you should have only reuse it. I will write as I4. So we are in I4, we have completed till f derives open braces. We have the last rule, that is go to of I4 comma it is id. So f derives id dot. So please check whether we have the same rule. Yes, we have it in I5. I will name this as I5. Now we are done with I4. I5 is also completed. Next is I6. So go to of I6 comma, the dot has to move one step right of the non-terminal t. So I am going to write as go to of I6 comma t. So now let's do e derives e plus t dot, e derives e plus t dot. Yes, any other operations are possible, please check. Yes, so the next one more operation is t derives t dot star f. So there are no other production, that is followed by a non-terminal t. So that's all. Before naming it, as we discussed, we need to check. So please check. Okay, so I will name this as I7, I8 I have done. Now I will name it as I9. Okay, so I6 comma t is done. Next what we have to do is go to of I6 comma, the dot is followed by a non-terminal f. So go to of I6 comma f. So what happens here? T derives f dot. So this dot symbol will be moving one step right to it, and check whether there is any non-terminal that is followed by a dot. No, f. Okay, so only this rule. So t derives f dot, we have already done in I3. So I am going to use the same as I3 here. I am not going to give any new names here. Next is go to of I6 I have done for f. Now I need to, that is go to of I6 comma open braces. So it will be f derives open braces dot e close braces. After dot I have a non-terminal e. Okay, so closure is applicable here. So e derives, I have to take it from here, e derives dot e plus t. Then e derives dot t. After dot we have a non-terminal e, closure is applicable there also, because already we have taken care of that. I am just ignoring it. Moving on to the next, dot dot is followed by a non-terminal t. So closure is applicable. I will include it from here. T derives dot t star f, t derives dot f. So again after dot t, as discussed, I am ignoring it. After dot I have a non-terminal f. So closure is applicable here. So I will include the rule f derives, it is dot open braces e close braces, then f derives dot id. Okay, we need to check whether we have the same rule or not. Okay. So please check here, f derives dot e derives dot e plus t derives dot e. Okay, this is same. Okay, so I6 comma open braces, instead of giving it as a new name, I was supposed to give only the I4. Now I am done with I6. No, we have left out with f derives id. Okay, so we'll go to of, it is I6 comma, so it is go to of I6 comma id. So f derives id dot. So check whether we have the same condition here. We have f derives id in the place of I5. So I will use it as I5. Next, I6 is completed now. Next we will move on to I7. So I7, I have the first rule. Okay, so go to of I7 comma non-terminal f. So go to of I7 comma non-terminal f. So it will be t derives t star f dot. Only the one rule that has dot followed by f. So we are done with that. Before naming it, I will check for the any, already we have the same LR of LR0 items. There is no such condition, so I will name it as I10. Next, go to of I7, go to of I7 comma, this is open braces. So go to of I7 comma open braces. So what I will get is f derives dot open braces dot e close braces. So as we discussed, after dot we have a non-terminal e, that is closure is applicable here. So I will extend the rule, e derives dot e plus t, then e derives dot t. So after dot we have a non-terminal e, that is already taken care. Next, moving on to the next grammar, that is e derives dot t. Okay, dot is followed by a non-terminal t. So closure is applicable. So I will write as closure t derives dot t star f, then t derives dot f. So after dot we have a non-terminal t, that is already taken care. After dot we have a non-terminal f. So closure is applicable here. So f derives dot open braces e close braces, f derives dot id. Check for any other closure is applicable or not, because dot is followed by a terminal symbol open braces, and then the next rule dot is followed by id. Both are said to be a terminal symbol, so no other closure property is applicable here. So we will close this, and before we naming it, we need to check whether we have the same condition, that is same LR of 0 item. So we can reuse the state names. So I7 comma open braces, please check for this, it will be I4. Okay, so I4, the I4 and I7 comma open braces have the same kind of LR production items, right? LR0 items. So hence, instead of giving it a new state name, we are reusing the states I4. So I have written I4 there also. Go to of I7 comma id. Okay, so go to of I7 comma id. So I will get is f derives id dot. So that's it. I7 is over now. Okay, I need to name this. Okay, I will be using I5. We have completed with I7 now. Okay, so I7 is already over. This is ID, I7 is over now. Now we will move on to I8. Now I will write as go to of I8 comma. So refer here, we have dot symbol followed by a terminal close braces. So go to of I8 comma close braces. So I will be writing here as f derives open braces e close braces dot. Then this is a different. So I will try to check whether we have to reuse the state name or not. No. So I will write it as I. We have done with I9. So I will be writing it as I10. Next. Go to of I8 comma. So I am in I8. Now I need to move my dot symbol one step right of the terminal symbol plus. So I will write as go to of I8 comma plus. So it will be E derives E plus dot T. After dot I have a non-terminal here. So it will be T derives, get it from here, T derives dot T star F, then T derives dot F. After dot we have a non-terminal F. So closure is applicable here. So F derives dot open braces E close braces, F derives dot ID. So dot is followed by a open braces here, and here dot is followed by a terminal symbol called ID. Okay, so in these two places closure is not applicable. So we will close with this. So I will give you just a hint. So instead of checking all these productions, you can go with checking only the symbols. Okay, so you can leave the state followed by we have a symbol, right? So here we have plus symbol. So before naming this, I told you to check whether we have the same set of LR0 items. Instead of checking all these items, you can, this is just simple way, check for plus symbols alone. So here we don't have plus symbols, TF, no plus symbols are here. So this is plus symbol is here. Okay, now check for only this. Here check E derives E plus dot T, yes, same, first is same. T derives dot T derives dot T star F, both are same. Then T derives dot F, T derives dot F here also. Here F derives dot open braces E close braces, yes, same here. F derives dot ID, F derives dot ID. Okay, these two are same. Okay, so I am naming this as I6. So instead of searching for all, that is checking for all these productions, you can just go with checking the symbols. Okay, so these symbols will be easier for you to check whether they have same LR0 items or not. So now I have done with I8. Okay, so I8 I had only the two rules. I have done with now I will move on to I9. Okay, so in I9 E derives E plus T dot, that is already a completed grammar. So I will move on to next. So I will write here as go to of I9 comma, I have a terminal symbol called star. So I will write as star symbol. So it will be T derives T star dot F. T derives T star dot F. Dot is followed by a non-terminal F. So I will closure is applicable. So I will take it from here. F derives dot open braces E close braces, F derives dot ID. So as discussed, the dot is followed by a terminal symbols called open braces, and dot is followed by ID. Okay, the closure is not applicable here, so we can close it. As I told you, you can just check for the star symbols. Okay, whether the star symbols, where we have a star symbol, yes, we have a star symbol here. Now check only for these productions were same, yes, both were same. So I will name this as I7. Okay, now I am done with I9 also. Okay, so you need not to repeat for I3, I4. That is the reason why we are reusing the states. Okay, now I have done for I9 also. Now I will move on to check for I10. I10 T derives T star F dot is a completed grammar. which is it's a completed grammar. So we will not be able to do any further operations here. We will check for the next. It is okay. Sorry, it is a I11. Okay, I11. Check for I11. I11 is also a f derives open braces e close braces dot. Dot has moved to the right hand side corner of the grammar. So that's it. We have completed LR0 items. Okay. So this is the simple LR parser. We have started with augmented grammar, and we have proceeded wherever closure is applicable. We have extended the rule from this and go to operation till no more new states are possible. That is a place where you can stop this. Okay. So this is LR0 item for the given question e derives e plus t, e derives t, t derives t star f, t derives f, f derives open braces e close braces, f derives id. So in next class we will be discussing on how to construct SLR parsing table, followed by we will have some sample input and check how we are using this parsing table to check whether the input is parsable or not. Thank you.